Well, today I've got a KLV-S32A10, and I thought I'd go over some voltages and some troubleshooting steps with you on this model. This set uses a power supply board, part number A-1128-514-A, and the main board on this model is part number A-1107-288-A. So with the set off, I'm going to take a look at this connector right here. It is CN6203. It's right on the far right hand side of the video. And this is the standby 5 volt power supply. And you should have very close to 5 volts here. I've got 4.99. Now it's really hard to see, but there's a small transformer right here, kind of underneath my multimeter. And if you look very closely, you'll see D6305, and that's the rectifier. So if I check that, I should get the same voltage. This little power supply is the only thing that runs when the TV is off, generating the 5 volts for the microprocessor over on the main board. So I've got 5 volts here. The next pin is ground. The next pin is labeled power on, and that's the power on command from the main board to the power supply that tells it to turn on the main power supply to run the main board, the audio circuits, the backlight inverter, and so on. AC off detect is the next pin. Now right now I've got 4.1 volts, and that's going to change when the set goes on, but I'll show you how that works real quickly. And the last pin, pin 5, is ground. So let's take a look at power on command first. So I'm just going to hit the manual power button over here, and you'll see instantly it goes up to 2.88 volts, about 2.9 volts. And the relay clicked. I don't know if you could hear the relay click or not, but that turns on the main power supply. And now let's look at the AC off detect. And now what this line does is, in cases of power loss, it sends a command to the microprocessor letting it know that the power has gone off and that it needs to do an emergency write to the EEPROM, and that's what saves the data. And this, in my estimation, is sometimes why we get corrupt EEPROMs. If this circuit doesn't work correctly, or your main filter capacitor isn't up to 100% reserve capacity, when it tries to write data to the EEPROM, if the voltage were to drop to the microprocessor, it could potentially write some erroneous data or corrupt data to the EEPROM and glitch it. And then at that point, it may never work again. So looking at this right now, it's low, 0.08 volts. So I'm going to really quickly, I'm going to shut off the power supply, and you'll hear a click because it has a switch. And if you watch that voltage very closely, you can see it went up to about 2.5 volts, and that's what told the microprocessor instantly that there's a fault and it needs to try to write the data back to the EEPROM. So let's take a look at some of the other voltages real quick. Let me move my camera. Okay, next I'm going to look at CN6202 and CN6200. Now CN6202 is the voltage that runs the backlight inverter, and the set's off right now, and so the 4 left-hand pins, pins 1, 2, 3, 4, pins 1, 2, 3, 4, and 5 are all 17.5 volts. The other 4 pins are ground, so we should see basically 0 volts on all the pins over here, which we do. Looking at CN6200, the first 2 are ground, the next 2 are the regulated 17.5 volts, and then we have unregulated 33 volts. It's showing a volt. That's just because I had the set on a moment ago. And so residual charge in the filter capacitors. Now that's going to run the tuner. A lot of the tuners require 33 volts to run. Next couple of pins are ground, audio ground actually. And then unregulated 10.5 volts. That's the audio source. And then ground again, and then unregulated 15 volts. So everything's basically 0 except for the 33 volt source, which has a little bit of residual voltage charge in the capacitors. So let's go ahead and put the probe on. I'm going to use pin 2 of the 17.5 volt for the backlight inverter. I'm going to turn the set on now, and we'll see what we get. We get 18.2 volts before the inverter actually starts. Should pull down, and it did, 18.15. So that's pretty close. That's within a few percent. So I'd be happy if you had that. If you have no video, no backlight, take a look at this voltage and make sure you have your voltage here. Now let's look at the other voltages on the main power supply connector, CN6200. So unregulated 17.5 volts is the same as the backlight inverter, because you can see it's almost identical to within 1/100th of a volt. Let's look at the unregulated 33 volt source. I've got 36, almost 37 volts there. 10.5, which is the audio voltage regulation to the audio amplifier, which is over on the main board. So if you have no audio, check there, make sure you've got that. And then the last two pins are the unregulated 15 volts. I've got 15.7 volts right there. So if you've got a set like this and it's totally dead, it just won't even turn on, the first thing obviously is to check the AC fuse right here. We can put it on AC volts, and we can actually take a look inside the little connector right here, and we should see about 115 to 120 volts. Of course, different countries have different AC voltages. You may see 240 volts in some other countries. So let's go back to volts. I'm going to put this on the 600 volt range. And real quick, AC voltage comes in right here. It's filtered through these capacitors. There's a metal oxide varistor. There's a couple of inductive transformers. And another capacitor, another metal oxide varistor. And what this does, in addition to these little capacitors over here, is that smooths out the AC. It removes any radio frequency interference or electromotive force interference, EMI, RFI, from the AC signal coming in. And then it goes into a bridge rectifier right here. It's filtered by this capacitor. And this is all after power factor correction, which is what's done right here. This is the power factor correction circuit. And so what we should see when the set's on is we should see about 400 volts right here. Anywhere from 395 to about 410 is pretty standard for what I've seen on most of these sets. From then, it's real quickly, let's talk about power factor correction. And I've mentioned it on a couple other videos. And its job is to compensate for either inductive or capacitive loads, which can either lead or lag the sine wave of AC voltage coming in. So the current draw actually needs to be in phase with the voltage draw to be 100% efficient. If the current draw is either in front by a few degrees or in back by a few degrees of the AC voltage, the sine wave coming in, it makes it not as efficient and it generates excess heat. And with millions and millions of different little things plugged into the world out there, we try to make it as efficient as we possibly can. So power factor correction, after it's rectified, it actually has a very, very small capacitor, not even enough to hold a charge for one complete cycle. And so that ensures that the current is in phase with the voltage as it's being drawn, which causes it to be much more efficient, so less heat generated and much more energy transfer that way. Anyhow, after it leaves power factor correction, it goes through, let me move my meter here real quick, it goes through a couple of transformers over here, which is where the main power is generated. This is the power supply controller IC. I've had a couple problems with those, but not as many as the old MCZ 3001s. So these are the FETs that drive the power supply, that drive the transformer. And then from there, it's sent over here to these rectifier diodes, which are on heat sinks, and then out the power supply lines I just talked about. So let's take a look at some voltages on the main board really quick. So as in all of my other videos, I'm using the jack ground on just one of the AV jacks. Here it is plugged in here, and that goes to my negative lead of my multimeter, and that's chassis ground. It's the same as any metal piece on the chassis, and I like the jack because I have a little clip lead I've made up, and it works out quite conveniently. Now, with the exception of power factor, which is on the hot side of the AC coming in, and that's isolated from ground. And when you saw me measure the voltage on the filter capacitor, the 400 volts, you notice I had the black lead on the negative side of the spare capacitor pad on the main circuit board. But other than that, I've always used the main ground, chassis ground, for my input. So let's take a look over here at the voltages that control the backlight real quick. So I've got the set off, and I'm looking at this little connector. I'm trying to see a number on it. Looks like CN8603, and it's only got 4 leads to it. So pin 1 and pin 2 are non-existent. Pin 3 is ground, and now pin 4 is labeled panel detect. So let's take a look at that. The set is off right now. Now I've just turned it on. We've got 0 volts. Let me see if when the backlight actually starts, if we see anything. We do, 2.5 volts. Now pin 4 is actually the backlight on-off command. So let's turn the set back off. Turn the set back on. And when the backlight starts, we should see this voltage go high. And this is simply an on and off command to the backlight inverter. So if you've got no backlight, take a look at this voltage really quick. And now the next pin after that is labeled dimmer. So once again, I'll turn the set off. And I'll turn the set back on. And we should see that voltage change a little bit. Normally when they first start the backlight, they start them at a lower level and then bring it back up. And it doesn't look like it on this model. It stays pretty consistent at 2.3 volts. If there's a backlight adjustment command in the menu, as you adjust this, you would see this voltage change from maybe a half a volt all the way up to 3.5 to 5 volts, depending on the model of the set specifically. Now looking at these other commands, there's other connectors right here, CN9405. Now that supplies the voltage to the digital board, which is where the tuner is and where the HDMI inputs are as well. So we've got regulated 17.5 volts on pin 1, which we have good. Pin 2 is ground. Pin 3 is 5 volts. Pin 4 is ground. Pin 5 is the panel 5 volts. Let's see, I must not have been on there. I think they must have mislabeled it because we've got panel 5 volts and panel 5 volts, unless I was off by 1 pin. I think I was. Ground and then standby 5 volts, and this is your 5 volt supply that you need all the time. Even if I turn the set off, which I just did, we still have 5 volts on that pin. Now let's take a look at these little voltage regulators right here. This is our higher voltage to lower voltage regulation circuit, and they're actually labeled, which is very nice. I don't know if you can see it on the camera, but we've got D5 volts, A5 volts. That's digital or analog 5 volt source, panel 5 volt source here. Way down here, it's really hard to see, but it's labeled D5 volt, A5 volt once again. So usually looking at these regulators while the set's on, we'll see an input voltage. Typically we'll see an output. There'll be a couple ground pins, and we might see a feedback. A lot of times I like to use 1.2 volts as the feedback. I've got 1.3 right there, so more likely than not that's the feedback pin. And there's a resistor network that divides that voltage back in to get it adjusted. So on this one I'm going to have to say pin 1 is input, pin 2 is the output pin, pin 3 is ground, pin 4 is the feedback pin, and then pin 5, which is an odd voltage, is probably the oscillator pin. There might be a resistor and capacitive network right there to set up the oscillation frequency. Let's look at the next one, a little bit smaller right here, and see if it's configured much the same way. 6.2, ground, 1.3, and a 3.2. So I would have to say it's almost exactly the same, 6.2 volts. Now the output always travels through a diode and a inductor network to smooth out the power supply, because it's a switch mode power supply. It's a little bit high. It's labeled 5 volts. I'm getting 6.2 volts on it, so you can check on each side of your inductor. Now some voltage meters may not measure accurately. The Flukes always seem to do quite well, but if you've got another lower grade kind of meter, it may not measure the voltage on the input side of the inductor as well as some of the other ones do. Now this one's going to be very hard to measure. It's labeled A9 volts, 3.2, 0, and 1.2. Let me see if I can get back in here to even measure these pins. So these are very tightly spaced, so be extremely careful when you measure these. So on pin 2 I've got 12.3, and pin 4 I do have my 9 volt output. So pin 4 of this one is the output. Make sure you use a very nicely sharpened probe. And let's take a look at this last one, D5 volt, A5 volt once again. So I've got pin 1, 3.2, pin 3 is ground, pin 5 should be the input, or the regulation feedback voltage. There's pin 2, 6.2 volts, and pin 4 is 5.3, which is our output voltage right here. It's nice on a lot of these sets, they give you a lot of little test points, and they let you know what you should see. I've got 4 little test points right here, and they're labeled, looks like A9 volts, panel 5 volts, and standby 5 volts. And they all correspond to what they should be, and there's a D5 volts here as well. Let's see about the main board real quick. If you've got an audio problem, this right here is the audio amplifier circuit, audio chip. These are the 4 inductors. There's one on the positive and the negative side of the audio line. You'll want to make sure that your audio, I think it was 17.5 volts, or excuse me, 10.5 volts, is getting to the audio chip. Let me see if there's anything else I can think of on this board I wanted to talk about. No other little regulators. Typically, anytime you'll see a capacitor, if you measure the voltage on it, you should see something on the positive side. You may have a voltage on the negative side, but in most cases you should have ground. So that's kind of a point to look for if you see a big capacitor here and you take a look at one side and you've got voltage and the other side is nothing. That pretty much indicates that is good. Let's see, let's take a quick look at the keypad and the remote control. So here's a keypad, and it's just a loose keypad, and it's only connected by 3 small leads on the back side. And so there's actually 3 little test points here. So what I'm going to do is I'm going to shut the set off, and it clicked off, and I'm going to just go down the line and press all the buttons while I have my probes on here. So without pressing buttons, let's take a look and see what we have on each pin, 3.3 and 3.3. So the first button I'm pressing is labeled enter, and it does absolutely nothing on pin 2, but it does make a change on pin 3. It takes it from 3.3 to 2.9. The next button, which is the Vega gate, Sony always called it Vega and they labeled it Vega for some reason, don't understand that. But it takes it from 3.3 to 2.4 volts. The next button takes it down to 1.9, and that's TV video. 1.9. After that, it looks like it's going to be volume down, and then volume up. Yes, that's correct. Volume down, volume up. And they're all on this key scan line on pin 3 right now. And we should start to get some buttons on key scan line pin 2, unless that's reserved exclusively for the power button. Channel down is 0 volts. Channel up is 0.5. So let's hit the power button right now. No change whatsoever. So let's go ahead and look at pin 2 right now. And it goes right to 0 when I press the power button. So pin 2 is exclusively used for the power button. Pin 3 is a resistance ladder for every other button on the input keypad board. So let's take a look at the infrared remote controller board real quick. Okay, so I'm looking at the little remote control board real quick. And right here is the actual infrared remote control receiver. It's got 3 pins to it. And they're actually labeled. You can see this one's labeled VCC. There's an O, which is out. So the first pin is 5 volts. This middle pin is ground. And the last pin is 4.9. And a way to test this, I'm going to just take the end of the remote control. And I'm going to stick it near here. Press the buttons, and you can see the voltage changes on the meter, which means it's picking up a signal. And if you look at ground, I'll press the button again. No change. 5 volts. 4.9 just because of loading. But now there's a lot of other pins here on this connector. And this model has some LEDs on this board that tell it when the set's on and when the set's off. It goes from red to green. Plus it has a LED that blinks if you've got a troubleshooting problem, an emergency shutdown. So you'll see that's what these other pins are for. But real quick, just looking at the pins. Pin 2 is the 5 volt source that supplies voltage to the infrared remote control receiver, and then pin 10 is the actual output. So those are the 2 pins you're really concerned with. Once again, I'm not going to get into the digital board on this set, which is under this metal cover right here, which is where the tuner is, HDMI inputs and things like that. It's a little too complicated to really get into at this moment. Over here, you got the backlight inverter board. You can measure the voltage on the pins itself. 17.5 volts for the main power supply. And then you've got the backlight on-off command and the dimming command, as well as the panel detect feedback line that lets the main board know if the panel's operating within specifications or not. Well, I hope you enjoyed the voltages and troubleshooting videos. Hopefully it'll get somebody set out of the junk pile. You know exactly what to look for. You can find out where your defect may actually be. I didn't get into the timing controller board on this one, or the LVDS cable. I've covered that on a couple of other videos I've done, and that's just because this is one of the earlier sets. It was built in 2005, so as of making this video, it's 10 years old. And it's got a big metal shield that covers the LCD panel, so it's extremely hard to get to the LVDS cable or the timing controller to make any voltage measurements. There is a 26-inch version of this set as well, so your boards may be the same in the 26 as well as 32-inch. Once again, I hope you like this video. Hope it helps you keep these sets out of the recycle bin or out of the dumpster. With your help, we can keep these things going. I appreciate your views, your support. I still try to answer questions, even though I don't get as much chance as I used to. Once again, you can follow me on Twitter at NorCal715. Yeah, everybody have a great day, and take it easy. Bye-bye.